We're literally witnessing one of the most fascinating shifts in the history of the US tech market right now. For years, the software development path felt pretty predictable. But artificial intelligence, it's completely rewritten the rules. Today, we are mapping out the AI engineer roadmap for 2026. For this explainer, we're cutting through all the hype, all the noise, and focusing strictly on the reality of the US job market. A market where the demand for specialized talent is, frankly, blowing past the supply. If you're a developer looking at your career over the next few years, understanding this landscape isn't just a nice-to-have advantage, it is absolutely crucial for your professional growth.
Okay, let's dive right into Section 1, the exploding AI job landscape.
To really grasp the absolute chaos of the current tech environment, look at this, a jaw-dropping 342% year-over-year growth rate in AI engineering job postings. I mean, take a second to really process that number. Companies across the US, we're talking everyone from massive Fortune 500 giants to lean little Silicon Valley startups, are waking up to the fact that they need to integrate AI into their products yesterday. The mandate from the top down is crystal clear: adapt or become obsolete. But here's the massive bottleneck they're hitting. They have the budgets, they have the vision, but they simply do not have the people to actually build these systems. In just 1 year, the number of companies hunting for developers who can implement AI has more than tripled. That's not a slow, creeping trend, right? That is a sudden, massive spike that's completely shaken up the standard tech hiring market. Every major tech hub, every remote-first company is aggressively expanding their headcount for this specific role. The demand is here, it's real, and honestly, it's desperate.
And that desperation is perfectly captured by this next figure, a 7-to-1 demand-to-candidate ratio. Think about that. For every single qualified AI engineer sitting in the US job market right now, there are 7 open roles actively fighting for their attention. It's wild. It's gotten to the point where recruiters are practically offering to walk your dog just to get you on a 5-minute screening call. The leverage has completely flipped to the developer. It totally explains the crazy bidding wars, the massive sign-on bonuses, and just the flood of frantic recruiter messages in your inbox. Companies are fiercely competing against each other because the talent pool is just so incredibly shallow. But here's the kicker. Despite all this incredible leverage, a lot of developers are freezing up. They just aren't applying. And the reason why? It boils down to one massive misunderstanding.
Which brings us to Section 2, the AI engineer misconception.
When most of us hear the words artificial intelligence, a very specific, kind of intimidating image pops into our heads. We instantly picture overly academic environments, whiteboards covered in insanely complex math, linear algebra, calculus, just dense algorithmic theory. There's this deep, common fear among developers that getting into AI means you have to go back to school, get a PhD in data science, and spend years studying math. And that fear is a massive artificial barrier. It's keeping incredibly talented software engineers out of literally the most lucrative market of the decade. But let's pause for a second. Do you actually need to train models? Do you, as an AI engineer, have to build fundamental intelligence from the ground up?
And this brilliantly illustrates the reality. There is a huge distinction here. On one side, you've got the ML researchers and data scientists. These are the academics, the PhDs, spending millions of dollars and months of computing power to train core models completely from scratch. But the AI engineer, they build production systems using existing models. You're basically taking the incredibly powerful tools that those researchers built, and you're applying them to real-world software to solve actual business problems. It's kind of like the difference between baking a complicated cake totally from scratch, milling your own flour, refining your own sugar, versus taking an amazing store-bought cake and decorating it perfectly for a specific client. You aren't inventing the intelligence. You're wiring it into real-world applications. So the crucial takeaway is this. You do not need to be a mathematician to be an AI engineer. You just need to be a software engineer who knows how to use these existing tools in production environments.
So let's look at Section 3, the 4-stage career ladder.
Once you realize you're just applying existing models, all that panic just kind of fades away. You don't have to jump off an academic cliff. Instead, what you have in front of you is a really clear, highly actionable path forward. The applied AI engineering route isn't some mysterious dark art. It's a straightforward 4-stage career progression that lets you start exactly where you are today. Let's move through this and see how it builds, step by step. Step 1 is the AI Augmented Software Engineer. This is where you're just doing your standard day-to-day software job, but you're bringing in AI tools, like advanced coding assistants, to radically boost your own personal productivity. You're just getting your hands dirty and getting comfortable with what the tech can do. Then you step into Step 2, the true AI engineer. Here, you transition from just using AI for your own speed to actually integrating AI models into your company's products. You're building user-facing features powered by existing models. Step 3 is the senior or staff AI engineer. Now, at this level, things get deeply interesting. You're designing complex systems, optimizing how these models perform, handling massive data pipelines, and ensuring the AI doesn't hallucinate. You're making sure it's reliable, secure, and cost-effective in live production. And finally, step 4 is the pinnacle: AI engineering manager or architect. Here, you're leading entire teams, setting the strategic vision for how the whole enterprise leverages artificial intelligence and designing the high-level architecture of enterprise-scale AI systems.
Now, what's really interesting about this breakdown is how these stages anchor directly to current market value. Look at the baseline for an AI-augmented software engineer. You're looking at standard U.S. developer salaries, typically in the $120,000 to $160,000 range. But the second you make the jump to step 2, the dedicated AI engineer, your baseline jumps significantly, pushing into the $150,000 to $220,000 bracket. Remember that 7-to-1 demand ratio we talked about earlier? This is exactly where it shows up in the real world. Then we look at step 3, the senior or staff AI engineer. Because you are now the person ensuring these massive production systems don't fail, the value you bring to a U.S. corporation is immense. We're talking commanding salaries anywhere from $200,000 up to $350,000. And finally, at step 4, the manager or architect level, where you're driving the core AI strategy for the business. Total compensation packages routinely hit $300,000 and can easily scale past $500,000 a year. Clearing up that math misconception and systematically climbing this specific ladder is, hands down, one of the most financially impactful things a developer can focus on right now.
This massive shift in the tech market is happening right now, which leaves us with one critical question. Will you be the one adapting to leverage this new reality, or the one left behind? Because as our source notes, in part 2, we're covering the exact skill path, in order, and why the order matters more than the skills themselves.
Welcome back to the Explainer. So in part 1, we kind of mapped out the whole AI career landscape, right? We looked at the literal ladder you need to climb to break into this booming field. Well, today, we're getting incredibly granular. We are going to figure out exactly how to climb that ladder, step by step. Basically, we're shifting gears. We're moving away from those high-level, big-picture goals, and we are mapping out a concrete, technical blueprint. Because, let's be real, if you want to be an AI engineer by 2026 blindly studying random topics, yeah, that just doesn't work. We need a systematic approach. Okay, let's dive into this. Here is our agenda for today. First up, climbing the AI ladder. Then we'll hit the core skill path, followed by advanced AI infrastructure. After that, we'll ground ourselves with some realistic learning timelines and finally wrap the whole thing up with getting hired. All right, section 1, climbing the AI ladder, and specifically the idea of a dependency pyramid. Moving right into section 2, the core skill path. This is your initiation phase. So here is the full 6-step sequential roadmap. We're going from Python to LLM APIs to RAG, orchestration frameworks, vector databases, and ending at deployment and MLOps. Now, what's really fascinating here is that this is absolutely not just some random laundry list of cool tech. It is a strict dependency chain. As we'll see in a second, you literally cannot learn step 4 without fully understanding step 3. So naturally, we have to start at step 1, which is Python. This is your absolute foundation. Why does Python come first? Well, because it's the fundamental programming language you need before you can even touch or connect to any AI models. It's kind of the lingua franca of machine learning. Almost every major AI library, framework, and tool out there is built for Python. Without a rock-solid grasp of it, the door to AI engineering is just completely locked. Once you've got that Python foundation completely locked down, step 2's dependency opens up for us, and that is LLM APIs. These are application programming interfaces. In simple terms, once you know Python, you use these LLM APIs to plug your code directly into the AI's brain. So instead of just typing to an AI in a web browser, these APIs let your Python script send prompts and receive text programmatically. You're essentially giving your code the ability to reason. And this brilliantly illustrates exactly why RAG is step 3. RAG stands for Retrieval-Augmented Generation, because here's the problem we run into. LLM APIs are amazing, but they only know what they were initially trained on, right? They completely lack your specific data. They have no idea about your company's proprietary documents or your personal databases. So RAG absolutely must be added next to give the AI a contextual memory. It basically retrieves your specific, private data and feeds it straight to the LLM API, which suddenly makes the AI actually useful for specific business problems. Okay, Section 3, Advanced AI Infrastructure. This is where we talk about scaling all of this into production, which immediately dictates Step 4, Orchestration Frameworks. Think about how this naturally follows RAG. Once you actually start giving an LLM a memory, and you're asking it to fetch external data, maybe make a decision, and then execute some subsequent task, your workflows get unbelievably messy, fast. Orchestration frameworks step in right here to manage that exact complexity. They organize those multi-step AI tasks so your application doesn't just collapse under its own weight the second you try to do more than one thing at a time. So the crucial point here is that as your orchestrated workflows really start to scale up and they're handling massive amounts of documents and contextual data, standard databases, they just fail. They literally aren't built for it. And this creates an immediate dependency on vector databases. These are highly specialized storage systems designed specifically to handle high-dimensional AI data, which we call embeddings, and do it incredibly fast. You absolutely need them to instantly search through millions of documents so your RAG application can actually find the exact right piece of information in a matter of milliseconds. To finally conclude this technical path, we reach Step 6, which is deployment and MLOps, or machine learning operations. This is the final boss, basically. You take this entire stack we just talked about, the Python, the APIs, the RAG systems, the orchestration frameworks, the vector databases, and you push it live reliably. MLOps ensures your AI applications don't just work nicely on your own laptop, but actually function securely and consistently for thousands of real-world users out there. Because, let's be honest, an AI that only works on your personal laptop isn't an application, it's just a really fun party trick. But wait, hold on. Let's stop for just a second. How long does this actually take? We really need to hit pause on all this technical jargon for a minute. We've been throwing around some pretty heavy concepts, but let's bring it all back down to earth and talk about the harsh reality of actually tackling this pyramid. That brings us to Section 4, Realistic Learning Timelines. It's time to manage some expectations here. Now, what's really interesting here is the stark contrast in these timeline ranges. We basically have a faster track for existing software engineers versus a slower track for anyone starting entirely from scratch. Look, if you're already a software engineer, you already know Python, right? You know systems architecture. You're really just learning the AI-specific nodes on top of what you already do. So that might take you a few months. But if you are starting from absolute scratch, meaning Step 1 is a completely foreign language to you, you're looking at a much slower track. You're likely looking at a year or more to legitimately master this whole chain. We really have to ground these timeline ranges in reality, though, by talking about the weekly time commitment. Reaching the end of this 6-step roadmap is entirely dependent on a realistic, consistent weekly time commitment. Whether you're on the fast track or the slow track, you absolutely cannot achieve this by just casually watching videos on the couch. It requires dedicated, consistent hours every single week. Writing code, breaking things, fixing errors over and over again to truly build the muscle memory required for actual AI engineering. Let's move to and see how this builds into Section 5, Getting Hired and Next Steps. Learning the tech is deeply satisfying, for sure, but getting hired requires moving way beyond just the skills. The hard truth here is that having the skills from that dependency pyramid, that's really only half the battle. You can completely master RAG and vector databases, but proving those skills to a hiring manager or a recruiter is an entirely different game altogether. Ultimately, it is the proof that gets you hired. The source material leaves us with this exact final thought. In Part 3, we're covering the exact kind of portfolio that actually gets you hired and the mistakes that keep most people stuck. So, you gotta ask yourself, now that you have the complete blueprint to build the pyramid, are you ready to prove you can climb it? Or will you stay stuck at Step 1? We'll see you in the next explainer to find out.